Hello everyone, here's for another tutorial video to show you Circuit Simulator. The first one I'm going to show you to is Falstad. Falstad.com, you come in here and you see here it has Circuit Simulator. It is a very simple Circuit Simulator but quite powerful. It can run on your browser. You don't need to install anything if you don't want to install the Circuit Simulator into your computer, though I highly recommend you to install this guide layer for this module, so it's called LT Spice. It's not spice for food. Spice is what we call a circuit simulation. It's a technique. So this one we're going to see in the next video. But for this video, let's focus on the simpler one. Just click into Circuit Simulator. You can see it here, but we can come to the full screen version, and we have it right here. So here we can see a circuit that consists of a resistor, an inductor, a capacitor, a power supply, another resistor right here, and a switch. So this is an interactive circuit simulator. So if I click onto this, you can see that I close the switch, and then the current starts to flow here. And then if I open, it stops to flow here because the current is interrupted, and then it starts to oscillate around this guy. This is a fairly advanced kind of circuit for this module, for this stage of the module at least, so I'm not going to delve too deep into it. Just know that you already know an inductor, it stores magnetic energy, a capacitor stores electric energy. So the moment that I don't have anything supply energy to them, they're going to release that energy. And you can see here, as we have a resistor, the resistor heats up with the current, converts electric energy into thermal energy, and you see here the voltage in green decreasing with time, and the current in yellow also decreasing with time because they're proportional. You see the voltage and the current, they are not aligned. We call this, they are out of phase. This is something introduced by the capacitor and the inductor. But again, don't worry about it. I'm going to zero this out, and we're going to see a circuit that is a lot simpler. So just come here, and whenever you come to Falstad, you will be always presented to the circuit. Just need to click here, new blank circuit, and you have it. You have your blank circuit. So the most important tab for us here is the draw. So you can see I have shortcuts, which I'm going to use. I have the wire shortcut, the resistor shortcut, so two very important ones. Passive components, so this is where I can add capacitors, inductors. Not going to do this into this video, too advanced for that for now. But you can see here a lot of things do have shortcuts, and you can see that the shortcut is case sensitive. So if I press R, I have a relay. If I press small r instead of capital R, I add a resistor. If I press V, I have a voltage source with two terminals, G for the ground, and here I have outputs and labels, so I can add an LED for an example, voltmeter, an ohm meter, an ammeter to measure the current. I can add a few things here, watt meter to measure the power. So all of this you will find right here. And here I have my active components, not going to that. Building blocks. So we're going to use this later, the operational amplifier, into this module when we learn about amplifiers. Not now, all right? Don't need to worry about this right now. But just know they're very easy. The equation is as simple as the voltage divider equation, so don't worry about it. And the kind of circuitry that you're going to be building, again, it is very simple to do. We have a logic gates for some digital electronic things. I'm thinking of showing you this later into this module as well. We have some chips for digital electronics. We have our analog and hybrid chips, with not really going to go into details because it is a little bit too advanced for this. And we have the select and drag for space or shift. So shift drag, I'm going to show you how to do this. I have our scopes here, and I have my stuff. So if I don't want to use European resistors, if I want to use the American one, I'm going to click here, and if I press R, you see that I have this kind of resistor. Then if I show European resistors, it changes to this. When I am writing my own circuits, I usually do this. I'm not very good at drawing, and my inductor looks like a resistor, so I prefer to put it like this, so to avoid mistake. So if I press Shift and left mouse click over it, I can drag. But if I don't press Shift, you'll see that I create another element here. To delete something I don't want, I just put my mouse on top, don't click anything, press delete, and it deletes. So for this first video, let's just do some basic voltage divider circuit. I'm going to press the V for voltage. You see now that I have a cross, and I'm going to drag, usually from bottom to top, to create our voltage source. If I double click on it, I can choose the voltage, so let's put like 20 volts. Although the voltages we're handling with the Arduino are a lot smaller than this. It's maximum 3.3 volts. So I'm going to apply, and if I hover my mouse on top, I can see on the right side of the screen here, where you can see the time, that it is not producing any current, so 0 amps, because I don't have a closed circuit. And I have the voltage over the terminals of this voltage supply is 20 volts. See. So I'm going to press R to create my first resistor. And then R, I'm already in resistor mode, so I don't need to do it. I'm going to put another click here, and you will learn why I did this like that, not overlapping them very soon. I'm going to press W now for my wire mode. So I'm in wire mode. I just drag this up here, drag this up here, and of course I have missed a little bit here, and drag from here to here, drag from here to here. So you see that whenever I cross my my cross on top, I can see the points of those wires. The reason for me doing this is that within Falstad, if I add a component without touching terminals like this, it is not going to be recognized. For an example, if I get here, let's see, I want to measure the voltage. So here I have 20 volts and two resistors of equal resistance, so the voltage should be divided equally. Therefore, we should have 10 volts over this guy, and we do, and 10 volts over this guy. And according to Ohm's law, 20 volts is equal to the total resistance here, 2 kilo ohms, times the current. So the current is equal to 20 divided by 2000, which gives me 10 milliamps, which is being supplied by the voltage source. Now let's add here not a scope, but I want to add output and label. So I'm going to add here a voltmeter, and I'm just going to put it in between these guys without touching the terminals. You see that it does not work. So what I need to do is just connect my voltmeter, and you can do that. Don't do this. This looks ugly, but just to show, it does tell me that it is measuring -10, because you can see here. Sorry, let me zoom in. I forgot to do that. So zoom in here. So we have 10 volts. The positive is inverted. So let's delete this. And so draw, output and labels, voltmeter, drag. Oh, in this case here I have to drag from top to bottom. And I'm going to press Shift to drag it up. And then use my wire to measure the voltage. And you can see here I have my voltmeter. I don't have any current flowing through my voltmeter, because a voltmeter, in theory, the theoretical voltmeter, the ideal one, it has an infinite resistance. So if the resistance tends to infinity, the current tends to 0, and this is exactly what we're seeing here. So it just measures the voltage across the sky. It doesn't measure the current. This is not how you measure the current in an electric circuit. To measure the current, you need to add it in series with your component that you want to measure the current. So in this case here, we have two resistors, and the current that flows through this one is the same through this one. So let's change things here, and I'm going to press Shift. Oops. Let's delete this wire, and I'm going to also delete this wire, and I'm going to add a resistor in the middle here, like so, like this, and I'm going to give it a space. I'm going to wire mode, bring it here, here, and here. You see that the current restores, but because this is open, this is an open circuit, there's no current flowing through here. Let me reduce the resistance of this guy. And if I close my circuit here with a wire, you can see that a lot more current flows through it, because instead of being 2000 ohms, this guy here has only 200. So the current through this is a lot higher than here. And if you hover the mouse on top here, we can see it's 100 milliamps. But if I want to see the current flowing here, I will just delete this, and I'm going to come to draw and outputs and labels and ammeter, and I'm just going to draw the ammeter. So we can see here that through this wire I have 100 milliamps flowing. If I add another resistor here, so I closed, no current, so resistor mode, come here to here, you can see now that this current is a lot smaller. All right, so this is it basically for this video. I just wanted to show these topics. If you want to view in a scope, you right click on the component and view in new scope, and you can see the scope right in here, and it's measuring the current in yellow and the voltage in green. If you want to make it more interesting, I can add here a AC and control the frequency of it. So here I have 40 Hertz, and you can see that the current now oscillates plus and minus, as well as the voltage. So this is how you do things in the simulator. If I increase the frequency here, you see that a voltmeter here, that's not in AC mode, and I cannot really change it here. It's not very useful, so we use a scope for that. In the classroom, we use the oscilloscope to see those waveforms. So if I increase the frequency here, we should see it going a lot faster now. So hope this helps, and then in the next video I'm going to show you how to operate with LT-Spice, which is a really good spy simulator. It is advanced, but it can also do the basic things and show you everything that we have in here. So this is it for this video. I see you on the next one and in the lectures. Bye bye.